Imagine floating in the darkness of space, not near any star, not warmed by sunlight, just drifting endlessly. No sunrise, no seasons, no sky filled with stars that twinkle like distant lighthouses, just silence, cold, and the slow, eternal journey through the galaxy. This isn't science fiction. This is real. And the objects making this journey, they're called rogue planets. Now, here's the mind-blowing part. There might be more of these lonely wanderers in our galaxy than there are stars. Think about that for a second. More planets floating freely in the dark than there are suns lighting up the cosmos. That means for every star you see in the night sky, every speck of light, there could be 2, 5, maybe even 10 invisible worlds drifting unseen between them. How is that possible? And how do we even know they're out there? Let's dive in. So, what exactly is a rogue planet? Well, it's a planet just like Earth, Jupiter, or Neptune. But it doesn't orbit a star. It's not tied to any solar system. It's not getting warmed by sunlight. It's completely on its own, floating through interstellar space. Astronomers sometimes call them free-floating planets or orphan planets. They were likely born in a star system, just like the planets in our solar system, but some violent event or gravitational tug-of-war kicked them out into the void. And now they're just out there. Drifting alone. You might be wondering, how do planets get kicked out like that? It's not like they just decide to leave. The truth is, planetary systems are chaotic places, especially when they're young. When a star forms, it's surrounded by a swirling disk of gas and dust. Over millions of years, that material clumps together, forming planets. But during this process, things get messy. Big planets like Jupiter can gravitationally bully smaller ones. If a giant planet migrates inward toward its star, it can send shockwaves through the system, flinging smaller worlds out into space. It's like a cosmic game of billiards where one powerful strike sends another ball flying off the table. Computer simulations show that this kind of planetary ejection isn't rare. In fact, it might be the norm. Some models suggest that for every star, 1 or 2 planets get kicked out during the formation process. That alone could explain billions of rogue planets in our galaxy. But there's another possibility. Some rogue planets might never have been part of a star system at all. They could have formed directly from collapsing clouds of gas and dust, just like stars do. But instead of gathering enough mass to ignite nuclear fusion and become a star, they stay small planet-sized and just float. These would be more like failed stars than escaped planets. Either way, whether they were ejected or born alone, they're out there. And they're everywhere. Now, here's the big challenge. How do you find a planet that gives off no light? That's like trying to spot a rock in a pitch-black room. Rogue planets don't shine. They don't reflect starlight because there's no star nearby. They're practically invisible. So how do astronomers detect them? Well, they use a phenomenon called gravitational microlensing. This is one of the most elegant and mind-bending tools in astronomy. Here's how it works. When a massive object, like a planet, passes directly between us and a distant star, its gravity bends the light from that background star, acting like a lens. For a brief moment, the star appears to brighten. The amount and duration of that brightening can tell us about the mass and distance of the invisible object causing it. It's like seeing a ripple in a pond and knowing something passed through, even if you didn't see it. Microlensing events are rare and random. You have to stare at millions of stars for years, waiting for one of these tiny flashes to happen. But when they do, they reveal the presence of something dark and massive, often a rogue planet. And over the past couple of decades, surveys like OGLE, the Optical Gravitational Lensing Experiment, and MOA, microlensing observations in astrophysics, have detected dozens of these events that point to free-floating planets. One of the most famous microlensing detections was in 2011, when a team, using data from the Canada, France, Hawaii telescope, and the MOA survey, found evidence for up to 10 Jupiter-sized rogue planets just in one small patch of the Milky Way. Later, in 2020, a study published in Nature Astronomy suggested that rogue planets could outnumber stars by a factor of 2 to 1. That would mean over 100 billion of them in our galaxy alone. And that's just the ones we can detect. There could be even more smaller, Earth-sized rogues that are too faint to catch with current technology. But here's where it gets even wilder. Some rogue planets might not be completely frozen wastelands. You'd think that, without a star, any planet would be a ball of ice, colder than anything we can imagine. And yes, the surface would be brutally cold, hundreds of degrees below zero. But deep inside, things might be different. Planets generate their own heat. Earth, for example, is still warm inside from the energy of its formation and from radioactive decay in its core. That heat drives volcanoes, tectonic plates, and even supports life in deep-sea hydrothermal vents. A rogue planet could have a similar internal heat source. If it's large enough, say, the size of Neptune or even Earth, that heat might be enough to keep a subsurface ocean liquid beneath a thick icy crust. Imagine a world where, miles below a frozen surface, a dark ocean sloshes around, heated from below, possibly hosting microbial life. No sunlight. No atmosphere to speak of. Just a hidden sea in perpetual darkness. It sounds like a sci-fi nightmare, but it's not impossible. In fact, we have a real-world example right in our own solar system. Europa, one of Jupiter's moons. It's covered in ice, but scientists believe there's a vast ocean beneath. And if Europa were flung into interstellar space, it might still hold onto that ocean for billions of years. So could a rogue planet with a subsurface ocean become a kind of life-preserving ark, carrying microbes or even simple organisms through the galaxy? We don't know. But it's a tantalizing thought. Now, let's talk numbers. How many rogue planets are really out there? The estimates vary, but they're all staggering. A 2021 study using data from the Japan-New Zealand collaboration, MOA2, estimated that there could be nearly twice as many rogue planets as there are stars in the Milky Way. Other studies suggest the number could be even higher. Some researchers think there could be hundreds of billions, maybe even trillions, of these dark wanderers. And it's not just big ones. While early microlensing surveys were best at finding Jupiter-sized objects, newer observations are starting to hint at a population of smaller, Earth-mass rogue planets. In fact, some models suggest that smaller rogues might be even more common than giant ones. That makes sense. Smaller planets are easier to eject from a system, and they form more frequently. So the galaxy might be filled with countless Earth-sized worlds, each one a frozen, silent sphere drifting through the void. But here's the kicker. We're probably only seeing the tip of the iceberg. Current microlensing surveys can only detect rogue planets that are relatively close, within a few thousand light-years, and only when they happen to pass in front of a background star. Most of them go completely unnoticed. That means the real number could be far higher than what we've observed so far. So what would it actually be like to stand on a rogue planet? Let's imagine you're there, somehow surviving the cold, protected in a high-tech suit. The first thing you'd notice is the silence. Not just quiet, total, absolute silence. No wind, no rustling, no distant animal calls. The atmosphere, if there ever was one, has long since frozen and collapsed onto the surface. The ground beneath your feet would be a mix of water ice, frozen nitrogen, methane, and carbon dioxide, like walking on a glacier made of dry ice. Look up. The sky would be stunning. Without an atmosphere to scatter light, the stars wouldn't twinkle. They'd be sharp, bright points of light, unmoving. The Milky Way would stretch across the sky like a river of diamonds. It would be the clearest, most beautiful night sky imaginable, but also the most haunting. Because no matter how long you wait, the sun would never rise. There would be no dawn. No change in light, just eternal night. And the cold, oh, the cold. Surface temperatures on a rogue planet could drop below 240 DC to 400 VC, C400 VC. That's colder than liquid nitrogen. Any exposed metal would shatter. Electronics would fail. Only the planet's internal heat, seeping up from the core, might offer a faint warmth deep underground. If you could tunnel down far enough, you might find a place where water stays liquid, shielded from the void. But on the surface, it's a tomb, a frozen monument to a world that once had a chance at life. Now, you might be wondering, if these planets are so dark and hard to find, how will we ever learn more about them? The answer lies in the next generation of space telescopes, especially one that's about to change everything, the Nancy Grace Roman Space Telescope. Named after NASA's first chief astronomer, the Roman Space Telescope is set to launch no later than 2027, and it's going to revolutionize our search for these dark wanderers. It's often called the wide-angle Hubble, because while Hubble gave us deep, narrow views of the universe, Roman will scan huge swaths of the sky with incredible precision. Its primary mission includes a microlensing survey that will monitor over 100 million stars toward the center of the Milky Way, exactly where microlensing events are most likely to happen. Roman's sensitivity will allow it to detect rogue planets as small as Mars, or even smaller. It could find thousands of them over its mission lifetime. And because it will observe so many events, scientists will be able to build a real census of rogue planets. How many there are, how their masses are distributed, and whether Earth-sized rogues are common. This could finally answer the question, are rogue planets really more numerous than stars? But Roman isn't the only hope. Ground-based observatories are also stepping up. The Vera C. Rubin Observatory, currently under construction in Chile, will begin an unprecedented 10-year survey of the southern sky in the late 2025. Using its massive 8.4-meter mirror and a 3.2 gigapixel camera, it will scan the entire visible sky every few nights, looking for changes, like the sudden brightening of a star due to microlensing. It's expected to detect tens of thousands of microlensing events, many of which could be caused by rogue planets. Then there's the future of direct detection. Right now, we can't take pictures of rogue planets. They're too faint and too far. But in the coming decades, extremely large telescopes like the Giant Magellan Telescope and the European Extremely Large Telescope might be able to capture infrared images of the very nearest rogue planets. These worlds still emit a faint glow from their internal heat, mostly in the infrared part of the spectrum. With powerful enough instruments, we might actually see them, not as points of light, but as tiny disks in space. And let's not forget about the search for life. If rogue planets can harbor subsurface oceans, they become targets in the hunt for extraterrestrial life. Future missions might one day send probes to the nearest rogue planets, especially if one passes relatively close to our solar system. In fact, astronomers believe that a rogue planet comes within a light year of the Sun every few 100,000 years. One day, we might even find one within interstellar probe range. There's also a deeper philosophical side to all this. Rogue planets challenge our understanding of what a planet is and where life could exist. For centuries, we thought planets were only those bodies orbiting stars, worlds bathed in light and warmth. But now we know that the universe is far more diverse. Planets can exist in total darkness. They can survive without stars. They can carry the ingredients for life far from any sun. And if rogue planets are indeed more common than stars, then most planets in the universe may never see a sunrise. Most worlds may be cold, dark, and alone. That flips our perspective. Earth isn't the norm. It's the exception, a rare, lucky world that formed in the right place at the right time around a stable star. But the majority of planets, they're out there in the cold, wandering the galaxy like ghosts. So what's the takeaway? Rogue planets aren't just a curiosity. They're a fundamental part of how planetary systems form and evolve. They're evidence of the chaos and violence that shapes galaxies. And they might even be silent cradles for life in the most unexpected places. As we look to the future, with Roman, Rubin, and next-gen telescopes, we're on the verge of uncovering a hidden population of worlds that outnumber the stars. We're about to discover that the galaxy isn't just full of suns and their orbiting families. It's also filled with orphans, wanderers, lost worlds, and who knows? Maybe one day a rogue planet will pass close enough for us to study up close. Maybe we'll find evidence of chemistry or even biology thriving in the dark. Or maybe we'll just stand in awe of a world that survived the ultimate exile, forever adrift, yet still holding on. The universe is stranger than we ever imagined. And the more we look, the more we realize. The dark between the stars isn't empty. It's alive with lonely planets, each one a story of survival, ejection, and silent endurance. So the next time you look up at the night sky, remember, between those twinkling stars, there are countless invisible worlds drifting by. You can't see them. You'll never feel their gravity. But they're there, and they might just outnumber everything that shines. That's the mystery of rogue planets. Not just that they exist, but that they might be the most common type of planet in the galaxy. And in the grand story of the cosmos, they're a reminder that sometimes the most important things are the ones we can't see. If you enjoyed this journey into the dark and want more deep dives into the hidden wonders of the universe, hit that subscribe button. It really helps the channel grow. And if you've ever looked up and wondered what's out there, you're not alone. We're all searching together. I'll see you in the next video.